with Lazy B. In this video, we'll be discussing a question of JEE Mains 2024. And this is from the topic of limits and derivatives and continuity. So, you are given a linear function gx. So, by linear function, you mean that the function is of this form where a and b are real numbers, since this is a real valued function. And we have another function fx, which is given by this. Fx is continuous at the point 0. And f prime 1 equals to f at the point -1. And you have to evaluate g3. That means you have to find out this 3a plus b. So to find out this value, you just need to evaluate the values of a and b. And these will be found using the hypothesis, which is given that fx is continuous at x equals to 0. And the second one is that f prime 1 equals to f minus 1. Only this is the task for this question. So using the first hypothesis, they're saying that f is continuous at x equals to 0. This means that limit at fx extending to 0 from the negative side equals to the value at 0 and x approaching to 0 from the positive side fx. This is what continuity means at the point x equals to 0. Now, this is a into 0 plus b, because for the values of x which are less than or equals to 0, we have that fx equals to gx. So in that case, fx equals to gx, and our gx function is given by ax plus b. So f0 equals to a into 0 plus b, which is nothing but b. And for positive values, our fx is given by this 1 plus x upon 2 plus x raised to the power 1 by x. So this is how you are going to evaluate the b, because f0 is actually b. Now, if you are able to calculate this limit, you will be able to find out the value of b. Okay? So this is the limit. So b will be given by this limit. This is f. So you need to find out this. Okay? Which is given by now you can easily write this as e raised to power, look at natural log, because exponential and logarithm are inverses of each. So this is just going to give you an identity function, just this. This is equals to this. You just need to find out this, because this is what your x is tending to 0 from the positive side fx is. Okay, so now you have to find out the limit. Okay, now you know that the reason you are able to apply log over here is this, because you know that x is approaching 0 from the positive side. That means x is actually greater than 0. And this means that 1 plus x upon 2 plus x is also greater than 0. And if it is raised to some power 1 by x, which is well defined because x is not equal to 0, that means this is again a positive number, real number. And since the domain of log, natural log, is from 0 to infinity, and 0 is not included, and this value is greater than 0, that means this can become the argument of our log function. That is the reason we can apply log here. very easily. We don't have any doubt. Okay. Now you need to evaluate this limit. So to do this, you need to write this again. You know that exponential is a continuous function. I have mentioned this in the previous videos as well, that when you're talking about the continuous function and you need to evaluate this limit, this is nothing but fx or f at the point, because if there is a function f and this is continuous function and you are talking about this limit, then this is nothing but f at the point c. And what is fc? It is actually f, the limit of the identity function when x is going towards c. So of course this will be c only, and this is going to be equals to this. So this is what we are going to use for an exponential function as well. Because our exponential function is continuous function, so interchanging the limit and the function won't be a problem. We can easily send this inside the argument. It is only possible if the function is continuous, and since we know that our exponential function is very much continuous, this won't be a problem. Now you can use the property of log, which says that log a raised to power b, and delete this. We don't need it anymore. We can use log a raised to power b is b log a. That means we can bring the power forward. So that means we can bring this forward. Now we just need to find out this limit. And now if you see them separately, then you know that limit x tending to 0 from the positive side, 1 by x is just plus infinity. And limit x tending to 0 on the right hand side of this function is going to be log half, which is actually a negative value. So using the extended product rule, see, when both the limits, individual limits are finite, you know that you can separate the limit for this, and the limit will be the product of the individual limits. But if you know that one is infinity, one limit is infinity, and the other is finite, then also the product rule holds. Then also you can apply the product rule. And you know that this limit is giving you a finite negative number. So the product will give you product rule holds even if one is infinite and other is finite, but it has to be non-zero. Because if one is finite and the other is zero, then it will become 0 into infinity form, which is an undetermined form. It is, if you can't determine this, okay? So it needs to be a finite non-negative, non-zero value. So you know that this is a non-zero value log, natural log at the value half, which is less than 0, and this is infinity, so it will be giving you e raised to power minus infinity. Because infinity multiplied with a negative number is e minus infinity, and you were just calculating this So what is this? This is just limit x going to minus infinity e raised to power x. And this is nothing but 0. So this limit comes out to be 0. And since f is given to be continuous at 0, so 0, and at 0 it is a into 0 plus b equals to b. This implies the value of b is 0. So you have evaluated the value of b, which is 0. Now you just need your a to compute the value of the function g at the point 3. Okay. Now you will need to use the other thing which is given f prime 1 equals to f at minus 1. Here f for x greater than 0 is given by this function. Now you need to calculate this f prime at 1. Okay, so I'll be doing it using logarithm only. Since it is greater than 0, it works. So taking log on both sides, you will be getting this. Now taking derivative or differentiating both sides, you will be getting fx is non-zero. For x greater than 0, it is non-zero. You can see this because this is always going to be something positive, and it is going to be power of fx is going to be the power of a positive number, and so it is going to be something non-zero. That is the reason you can apply log. Whatever you are doing, you should be having clear knowledge, because the moment you apply log to something, to a value which is 0, then it won't be possible, because log doesn't exist for 0 and negative values. Okay, so taking derivative, you get 1 by fx into 1 f prime x by chain rule, and if you leave this as it is, then, and again using the chain rule, now for this I applied product rule. Okay, and this is minus 1 by x squared. Derivative of 1 by x is minus 1 by x squared. So these two, this gets cancelled, and you have plus x, 2 plus x, and then the numerator is just get 1, and this is what you get. Now you have to evaluate f prime at the value, at the point 1. So substituting x equals to 1, you have to substitute x equals to 1. And f prime 1 is given by 1 by 2 into 3. Into f into 1. Now you know that fx is given by 1 plus x upon 2 plus x raised to power 1 by x when x is greater than 0. So f at 1 is just, you need to substitute x equals to 1 over here, and you get 2 upon 3. So multiplying it inside, you get 1 by 9 minus 2 by 3 log 2 by 3. So this is your f prime 1. Now this is given to be equals to f at minus 1 in the question. So f at minus 1, when x is less than or equal to 0, fx is just gx, which is ax plus b, and as we have already found that v is 0, so this is just ax. So f at minus 1 is given by a into minus 1, which is minus a, and this is equals to this. So this implies a equals to minus 2 by 9 plus 2 by 3 log 2 by 3. This is the value of your a, and b equals to 0. So now you have your a and b both. So that means you have your function gx, which is ax plus b. B is 0. A is given by this. You just need to substitute here, and you get minus 1 by 9 plus 2 by 3 log 2 by 3 x. Now substituting x equals to 3, because in the question you have to find the value of g at the point 3. So that means you just need to substitute x equals to 3. Just given by this, and multiply it. Okay. This, and your answer will be, okay, 4 by 9, because you can take the power inside. So is your final answer. So thank you so much for watching this video, and see you in the next video. Till then, happy learning.